Good morning, students. So, welcome back to our mathematics class. So, in the last class, we already discussed or we are already completed one exercise. So, that is related or belongs to areas of similar triangles theorem. So, now today the very important concept is we already know about that name, that is Pythagoras theorem. Yes, of course, we already use this particular theorem or condition in different kind of problems in earlier classes also, right? I hope you all remember when we use this kind of condition or this particular theorem in previous classes. So today we are not going to derive the exact Pythagoras theorem in this class. Before going to that theorem, Pythagoras theorem, I would like to give you an very important information about one more theorem. So that theorem is theorem 2.7. Before going to proof of that Pythagoras theorem, you should know about this statement. So this statement is very, very important for that kind of theorem. That kind of theorem means that is Pythagoras theorem. So you just observe here. Once I would like to tell you the statement of this theorem. This is not a statement of Pythagoras theorem. You should keep it in your mind. So before going to derive the proof of Pythagoras theorem, you should know about this particular theorem, right? So here, if a perpendicular is drawn from the vertex of the right angle of a right triangle, so right triangle means it is a right angle triangle, to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. So this is the statement of this theorem. So in this particular statement, we notice that, so here they are given one right angle triangle. You just draw a right angle triangle here. By considering this right angle triangle, they are given here a perpendicular is drawn from the vertex of a right angle of a right triangle. What is the vertex of a right angle of right triangle? So here ABC is a right angle triangle, and what is the vertex of right angle? So that is B. So you should draw a perpendicular from the vertex B to the hypotenuse AC, because they are given here. So a perpendicular is drawn from vertex of a right angle of a right triangle to the hypotenuse. So you just draw a perpendicular here. So perpendicular means you already know about perpendicular. Then what happens? Triangles on both sides. So triangles on both sides means here after drawing a perpendicular BD in triangle ABC, you notice that it is divided into two right angle triangles. So those two triangles are ADB and BDC. So these two are the two different triangles formed when drawing BD as a diagonal of triangle ABC. So then triangles on both sides of a perpendicular are, so here triangles on both sides, these two are the triangles on both sides means perpendicular. So perpendicular is there, so that is the common side of both the triangles, so both the parts of a triangles. So then those two triangles are similar to the whole triangle. ಸೊ ಅಂದರೆ ಅವ್ರು ಹೇಳ್ತಿರೋದೇನೆಂದರೆ, ಯಾವುದೇ ಒಂದು ರೈಟ್ ಆ್ಯಂಗಲ್ ಟ್ರಯಾಂಗಲಲ್ಲಿ ರೈಟ್ ಆ್ಯಂಗಲ್ ವರ್ಟೆಕ್ಸಿಂದ ಹೈಪೋಟಿನಸ್ಸಿಗೆ ಒಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ನ ಡ್ರಾ ಮಾಡಿದಾಗ ಅದು ಟೂ ಟ್ರಯಾಂಗಲ್ಸ್ ಆಗಿ, ಟೂ ರೈಟ್ ಆ್ಯಂಗಲ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಆಗಿ ಸಪ್ರೇಟ್ ಆಗುತ್ತೆ. ಆ ಟೂ ರೈಟ್ ಆ್ಯಂಗಲ್ ಟ್ರಯಾಂಗಲ್ಸ್ನ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ, ಅಂದರೆ ಈ ಸ್ಮಾಲರ್ ಟ್ರಯಾಂಗಲ್ಲು ಮತ್ತು ಹೋಲ್ ಟ್ರಯಾಂಗಲ್ಲು ಮತ್ತು ಈ ಸ್ಮಾಲರ್ ಟ್ರಯಾಂಗಲ್ ಮತ್ತು ಹೋಲ್ ಟ್ರಯಾಂಗಲ್ಗೆ ಏನಾಗಿರುತ್ತೆ, ಸಿಮಿಲರ್ ಆಗಿರುತ್ತೆ. ಆ್ಯಸ್ ವೆಲ್ ಆ್ಯಸ್ these two are also similar anta heluತ್ತೆ. So this is very important theorem, and this theorem helps us to prove the proof of Pythagoras theorem. So that's why I am going to discussing about this particular statement before proving that theorem, right? So now we moving on the some information about this theorem. That means you need not to write down the proof of this statement, you just remember or you just understand the exact meaning of this statement, that's it. ಸೊ ಅಂದರೆ ನಿಮಗೆ ಈ ಥಿಯರಮ್ಗೆ ಪ್ರೂಫ್ ಎಲ್ಲ ಇರುತ್ತೆ, ಮತ್ತು ಈ ಥಿಯರಮ್ನ ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳ್ಬೋದು, 5 ಮಾರ್ಕ್ಸು 5 ಮಾರ್ಕ್ಸ್ 4 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳ್ತಾರೆ ಅಂತ ಅನ್ಕೋಬೇಡ್ರಿ. ಈ ಥಿಯರಮ್ ಜಸ್ಟ್ ನಾಲೆಡ್ಜ್ ಪರ್ಪಸ್ಸಿಗೆ, ಸೊ ಇದು ಗೊತ್ತಿರಬೇಕು ಎಲ್ಲರಿಗೂ, ಅದಕ್ಕೋಸ್ಕರ. ಸೊ ನಾನೀಗ ಜನರಲಾಗಿ ಪ್ರೂವ್ ಮಾಡ್ತೀನಿ ಯಾವ ಥರ ಸಿಮಿಲರ್ ಅಂತ ತೋರಿಸ್ಬೋದು ಅಂತೇಳಿ, ಬಟ್ ಅದನ್ನೆಲ್ಲ ಬರೆಯೋದು ಬೇಡ. ಯು ಜಸ್ಟ್ ಟೇಕ್ ಡೌನ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ ದಿಸ್ ಥಿಯರಮ್, ದಟ್ಸ್ ಇಟ್, ರೈಟ್? ಸೊ ಯು ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್, ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಗಿವನ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಹೌ ಕ್ಯಾನ್ ಯು consider whether the statement is correct or incorrect? Yes, of course, statement is always correct. So statements of each and every theorems are true, but we know the reason why the statement is correct, right? So now we moving on this particular statement by using this diagram. So ಈ diagram ನ ಯೂಸ್ ಮಾಡಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. They are given here after drawing a perpendicular BD from a right angled vertex to the hypotenuse of a right angled triangle, then the triangles on both the sides of the perpendicular line is similar to the whole triangle. ಅವ್ರು ಹೇಳ್ತಿರೋದು ನೋಡಿ, 2 ಟ್ರಯಾಂಗಲ್ಸ್ ಆಗಿ ಸಪ್ರೇಟ್ ಆಯ್ತಲ್ಲ, ಈಚ್ ಟ್ರಯಾಂಗಲ್ಗಳು ಕೂಡ ಒರಿಜಿನಲ್ ಟ್ರಯಾಂಗಲ್ಗೆ ಏನಾಗಿರುತ್ತೆ, ಸಿಮಿಲರ್ ಆಗಿರುತ್ತೆ. ಸೊ ನಾವು ಯು ಜಸ್ಟ್ ಟೇಕ್ ಡೌನ್ ಹಿಯರ್ ಫಸ್ಟ್ ಒನ್, ವೆರಿಫೈ ಮಾಡಿ ನೋಡೋಣ ಅವ್ರು ಹೇಳಿದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಇದೆಯಾ ತಪ್ಪಿದೆಯಾ ಅಂತ. ಕನ್ಸಿಡರ್ ಟ್ರಯಾಂಗಲ್ ಎ ಬಿ ಸಿ ಈಸ್ ಹೋಲ್ ಟ್ರಯಾಂಗಲ್, ಆ್ಯಂಡ್ ಒನ್ ಮೋರ್ ಟ್ರಯಾಂಗಲ್ ಈಸ್, ಯು ಜಸ್ಟ್ ಟೇಕ್ ಡೌನ್ ಒನ್ ಪಾರ್ಟ್ ಆಫ್ ಎ ಟ್ರಯಾಂಗಲ್, ದಟ್ ಈಸ್ ಟ್ರಯಾಂಗಲ್ ಎ ಡಿ ಬಿ, ರೈಟ್? ಸೊ ಎ ಡಿ ಬಿ is also another right angle triangle. We know that in these two triangles we already know about one angle is equal, that angle is right angle. That's why angle ABC is equal to angle ADB, right? So these two are equal to 90 degree because we already know in the diagram. So now we know that we need to prove these two, we need one more angle to prove these two triangles are similar according to AA similarity criterion. ಹೌದಾನೆ? ಸೊ ಇವೆರಡು ಟ್ರಯಾಂಗಲ್ ಸಿಮಿಲರ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ಇನ್ನೂ ಒಂದು ಟ್ರಯಾಂಗಲ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇದೆ ನಮಗೆ. ಸೊ ದಟ್ಸ್ ವೈ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಇನ್ ದ ಫಿಗರ್. ಸೊ ಎ ಬಿ ಸಿ ಇನ್ ದಿಸ್ ಟ್ರಯಾಂಗಲ್, angle A is there, and ADB in this triangle also we notice one common angle, that is angle A. That's why you just observe here, angle BAC is equal to angle DAB, both are common angle. Therefore triangle ABC is similar to triangle ADB. I think you know about, I think you get my point about this particular statement. So now we moving on second one. You just consider second one here. Consider triangle ABC and triangle, right angle triangle BDC, right? BDC is also a right angle triangle, no? Second right angle triangle. So then I will just observe here also angle ABC is equal to angle BDC, because these two are equal to 90 degree, we already know in the given section. And then one more angle is needed, but here angle in triangle ABC, angle C is there. In triangle BDC is also angle C is there. That's why angle ACB is equal to angle BCD, both are common angle. That's why according to AA similarity criterion, triangle ABC is similar to triangle BDC, right? So this is the way to prove the two triangles of both sides of a perpendicular line BD, so those two triangles are similar to the whole triangle, similar to the whole triangle. So this is the exact meaning of this particular statement. I hope you all understand the exact meaning or proof of this statement. So once again I'd like to tell you the exact statement here. So the statement is, you just observe carefully because this is very important for upcoming proof of Pythagoras theorem. So ಅಂದ್ರೆ ಇದು ನಿಮಗೆ ಗೊತ್ತಿದ್ರೆ Pythagoras theorem ಅಲ್ಲಿ proof ತುಂಬಾ ಈಸಿ ಆಗುತ್ತೆ. ಸೊ ಅದನ್ನ ನಾನು ಡೀಟೇಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ, ಬಟ್ ದಿಸ್ ಇಸ್ ದ ಇಂಟ್ರಡಕ್ಷನ್ ಆರ್ ಇನ್ಫಾರ್ಮೇಷನ್ ಅಬೌಟ್ 2.7 theorem. So this particular statement helps us to prove the Pythagoras theorem. So that's why it is very important for further studies. So here, if a perpendicular is drawn from the vertex of a right angled triangle to the hypotenuse, so that is very important. So ನೀವು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ನ ಡ್ರಾ ಮಾಡಬೇಕು ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ, ರೈಟ್ ಆಂಗಲ್ ಆಫ್ ಎ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ ಟು ದ ಹೈಪೋಟೆನಸ್ ಆಫ್ ದಟ್ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್. So that is BD is the perpendicular. Then triangles on both sides of the perpendicular, triangles on both sides of perpendicular means here this one is one triangle and ADB is another triangle. These two triangles are present in either side of a perpendicular line. So then those two triangles are similar to the whole triangle as well as similar to each other, similar to each other. So this is very important statement for upcoming proof of Pythagoras theorem. I hope you all understand the exact meaning of this theorem, that is 2.7 theorem. So that's it for today's class. We'll meet you in the next class. Thank you.